And now we will proceed to our third speaker. It's a great and pleasure to meet and to introduce our third speaker, Professor Ahmad El Sarafi. He currently holds the post and professor of radiology at Suez Canal University, Egypt, visiting of radiology at Sharjah University, and CEO of Internal Radiology Center in UAE. Good morning, Professor Ahmad.
Good morning.
How are you, Doctor?
Great to be with you today, and look forward to great meeting, and I'm ready to kick off when you are.
Thank you, Doctor. Maybe we will proceed.
Am I on air?
Yes, Doctor.
Good. Okay, so you need my presentation, and that's exactly what we're gonna share.
Thank you, Doctor.
Okay. All right. I would like to start by thanking the conference organizers for inviting me to be part of this conference. This is my second time, and it's good to see participants in excess of 400 attending this virtual meeting. I sure hope my presentation proves useful, and they can have a few bits of information related to artificial intelligence to take back home with them. Now, the title of my lecture today is Artificial Intelligence in Imaging. It's pretty much a follow-up or a follow-on to my previous presentation last year, which was Artificial Intelligence in Healthcare. This year, it was decided that it would be a much better idea it's going to be a good idea to focus on imaging, which is what we all do in this domain. So, good morning to all conference attendees. Pleasure to be with you here. As for disclosures, I have nothing to disclose, at least for now. The opening slide to my presentation is a quote by Albert Einstein. I'm sure you all know Albert Einstein. You know how smart he is. I think unarguably the greatest mind in our modern time. And the quote goes as follows: I do not need to know everything. I just need to know where to find it when I need it. So it's not about knowing it all and being capable in every aspect of knowledge. It's about knowing the basics that would allow you to stand firmly when you need to proceed further. And this is really my objective today. I need to give you the basics of artificial intelligence, the fundamental principles, how it works. But by no means am I attempting to give you all the details and all the intricate workings of artificial intelligence. I just want you to know the basics that will allow you to embark on a journey into this amazing world of artificial intelligence. So that's for my opening slide. Now, for those of you who thought that AI is something of the future, that we are not dealing with AI now, and why bother with a 40-minute presentation on AI, I wanted to show them or prove to them that we are all touched by AI in pretty much all aspects of our life. When you wake up in the morning and you just get that phone and you want to check if you got any messages, it wouldn't do that unless it recognizes your face. And that's AI. So face recognition, that we start our day by doing, or a system does, to allow us access into our mobile phones, our means of communication with the outside world, is based on AI. Social media, Facebook, Instagram, Twitter, YouTube, All of these use artificial intelligence algorithms to predict what we like and to give it to us. So that's why my Facebook is so different from yours. My Twitter feed is so different from yours. So is my YouTube suggestions, because they're all based on how the system, how AI perceives me and understands my trends, what I like, what I dislike. And based on that, it will present material that would make sense to me and hopefully would keep me hooked on that platform. Email. You might not think your email has AI functionality in it, but it does. That's how it picks up spam. That's how it picks junk mail based on AI algorithms that are provided by the email service provider. So even your email uses AI in the background. You might not even know. Google search. If I were to search a word and you would search the same word, we'll get different answers because the results are based on our preferences, our trends, our backgrounds, and Google are pretty good at collecting information about us. And that's how they're providing us with the results. When you're doing a Google search, you cannot search all Google database. That would be crazy. But what Google does, it directs you, it channels your search to areas that would interest you and only you. And that's why it's so quick, because it doesn't search the whole internet for your results. It searches what might be of value to you, and that's AI. Google Maps, we all use Google Maps. We depend on them. But look at the way Google Maps suggests a route for your journey. It would give you options based on traffic, based on your travel preferences, based on your previous experiences. So even Google Maps uses artificial intelligence. Voice recognition, not as simple as you might think. Voice recognition has come a long way and really took off with the implementation of artificial intelligence. Now, it's not just the pitch of your voice, it's not just the notes, it's much more than that. It's the context of the sentences, the words, the context. There's so much going in there, and that's why voice recognition is nearing 100% accuracy. In fact, a lot of social media interactions now are based on voice recognition. I believe interaction with Google search is about 10% based on Google recognition now, but this is only expected to rise in the very near future. Banking security, I need not tell you that banking security is heavily utilizing AI. So when you make a transaction using your credit card, that information regarding that transaction is sent into a huge system that would track all your actions, that would predict your pattern of spending, that would probably send you alerts based on that. This is all banking security. But not only that, it will make sure that your transactions are safe. So it will easily pick any suspicious transactions and alert you. And a lot of the time would block your card in that case. Netflix, watching movies, not as simple as you might think. Look at the movies Netflix suggests for you. How come they know your taste in movies? It's because they're using artificial intelligence. It scrutinizes everything you've watched. It scrutinizes everything you've searched before. And it basically builds a profile for you. So when it's suggesting a movie for you, when it's returning a search result for you, that's based on the database. It's based on your profile that it has built over time. Starts small, gets really big. And the more you use Netflix, the better it gets at predicting what you want to watch or what you would like to see. Amazon, I think that's an example of how artificial intelligence is used in business optimally. Amazon, they gather information about each and every one of us, meaning every one of us who has an account with Amazon. They track your purchases, they track your comments, They track your feedback. They track your purchasing patterns to the point that now Amazon not only suggests what you might like, Amazon actually predicts what you're going to buy in the near future and prepares that for shipping for you. So when you click that button, that shipment is ready to go. They actually read into the future of what we're going to buy. So these are all aspects in our daily life that are markedly touched by AI. It's not just touched, actually, it's driven by AI now. So in this AI presentation, what am I going to tell you? I'm going to preview the history of imaging, because there's no way you could perceive the future unless you touch on the past. So I'm going to touch on that just to pave the way for the future. I'm going to overview the basics of AI. I'm going to discuss AI in imaging. That's my focus. But we know that AI is not just for imaging. So I will very briefly preview what AI is doing in the rest of the healthcare environment. So, history, you radiographers mostly are probably familiar, probably saturated with the history of radiography. This is Röntgen, his wife Anne, and this is the first clinical picture of Anne's hand in 1895. This was taken just before Christmas in 1895. But we know that we celebrate Radiology Day or Radiography Day on the 8th of November. So how come? First clinical image just before Christmas, 1895, and we're celebrating like a couple of weeks before that, because the first images were formed using X-rays were on the 8th of November. This is the actual date that X-ray was discovered, 8th of November. So discovery of X-rays, we had non-clinical images on the 8th of November, and then the first clinical image of Anne's hand on the day before Christmas, as 24th of December, 1895. Of course, radiology has evolved enormously over the years, from very basic equipment such as this to state-of-the-art machines, so this CT scanner. Also, the amount of radiation we're using in imaging has diminished drastically. So now we're using much, much less radiation. We've seen in my lifetime that transition of X-rays from hard copies, the films such as this, to being fully digital pretty much everywhere. Now, I do not think any radiology facility worthy of its name would still be using X-ray film. Everything is on PACS and displays on diagnostic monitors. We've seen X-rays evolving from these simple, flat X-rays to this cinematic rendering of 3D images. This is an amazing transformation. We've seen the utilization of X-rays increase phenomenally, from few studies being made in a day in a hospital or clinic to hundreds. Some hospitals are actually doing thousands of studies. So there is an exponential increase in the number of exams. But it's not only the number of exams, it's the number of images per exam. From 1 or 2 images to 100 images, maybe 20, 30 years ago, Now, a typical CT examination would be thousands of images, 2, 3, 4,000 slices. This is phenomenal. And handling such number of cases and such number of images calls for a lot of change. We've seen the X-ray report evolve from this handwritten report to voice recognition transcription, which is becoming very standard nowadays. So with this evolving over the years, we have noticed that the way radiologists interpret as an image hasn't really changed much. But I also have to bring to your attention that I'm a radiologist. So a lot of the content would be from a radiologist perspective, but it applies to everyone working in the radiology field, be it a radiologist or a technologist or an assistant, everything. But I'm biased by being a radiologist, by looking at things from a perspective of a radiologist, but it works for everyone. So the way we interpret images has not really changed, whether we see it from a hard copy film or it's from a monitor. So what is required to interpret such images, and what are the problems such reading entails? To read a radiology image, you need to have a minimum visual acuity below which you just would not see the components of that image. You need to be able to practice image reading using patterns of scanning visually that image, corner to corner, edge to edge. You need to be able to recognize patterns of normals and abnormals and normal variants. You need to have these patterns well in your brain, in your mind. What does that require? Training, experience. Not readily available in many parts of the world. So the problems when you are reading as a human being, you cannot avoid skipping areas in that image. You cannot avoid being distracted. And we have to admit that experience varies significantly between radiologists, leading to high error rates. How high? Up to 30%. I'm a radiologist, I admit that. So, what to do? With all these issues, we have a new kid in the block, kid named AI. Let's see what AI can do for us. We know that we as radiologists, we look at images, but also AI looks at images. AI is pretty good at looking at images. It's getting better. It's actually better than us, I have to admit, right now, as we speak. AI doesn't get tired, doesn't take vacations, doesn't get grumpy, doesn't have a wife and a kids that are giving them a hard time before they go out to work. It just works 24/7. What does that mean for radiologists? Let's see what this man says, Jeffrey Hinton, 2016. In a conference, publicly, he said, we should stop training radiologists right now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists. Why I'm taking this man seriously? Because he's the man who created deep learning. He's the man who envisioned convolutional neural networks which allowed booming of AI. So he knows a lot about artificial intelligence, and he knows a lot about the potential of artificial intelligence. But 4 years ago, it was his opinion that there's no need for radiologists in the future. Just give them 5 years. And don't train anymore. In fact, in his lecture, he said that radiologists now are like coyote. You probably know coyote, that fast, impulsive creature chasing the chicken, being oblivion to everything around him, to the point of not realizing that he's already over the edge of the cliff. And that's exactly what Jeff Hinton said. The radiologists are already over the edge of the cliff, but they do not realize it. And I remind you, Jeff Hinton is the guy who envisioned modern artificial intelligence with the convolutional neural network models. So, will radiologists be needed in the future? Let's see what other guys say. New England Journal of Medicine, very important journal in our field. And in 2017, this is what they thought. Machine learning would displace much of work of radiologists and pathologists. In fact, machine accuracy will soon exceed that of humans. We know it does actually right now. And our own publications, Healthcare IT News said, machine learning will replace human radiologists, pathologists, maybe soon. That was in 2018. Radiology Business announced that if you think AI will never replace radiologists, you may want to think again. So, I mean, it's an open and shut case, don't you think? Well, why am I not panicking? I should be looking for another job. So would my colleagues. I'm not panicking because I believe people who predict end of radiology do not understand radiology very well. Not even Jeff Hinton. He's an amazing computer scientist. He knows about computers much more than I'll ever know. Definitely. He's so unique. He's very high up there. But when it comes to radiology, workflow, I don't think he knows a lot. He just does not realize that radiology is not a perceptual task. It's not just looking at images and picking up lesions. There's much more than this. Radiologists are physicians. We specialize in using technology to make diagnoses. We've always done that. And we know that AI is getting good at some perceptual tasks. Actually, not all of them, but what it does, it's really good. However, where it cannot compete with us is with the cognitive tasks of diagnosing the full range of human disease. Computers are nowhere near what we can do. And this is what gives us job security for now. And I will refer to something from the past for you. When CT was new, well, healthcare professionals said, there's no need for radiologists. Now we have 3D images. We can look at anatomy. We can make up structures in a very clear manner. And look at these images. And they looked at them and said, who needs radiologists? But as it happened, although CT was claimed to be better at radiologists at evaluating 3D structures, it actually dramatically increased the diagnostic power of radiology. And doing so, it added so many new complexities. What does that mean for us? That CT created a huge demand for radiology. Now, there's more need for radiologists to deal with these CT images. So How do I see the future of imaging? AI is not ready to replace radiologists. Definitely not. AI will assist mainly with perceptual tasks in imaging. It's nowhere close to playing a role with cognitive tasks. So the future of imaging is going to be improved diagnosis that's going to be delivered by human radiologists working with AI. So it's going to be man and machine working together. And to reassure my fellow radiologists who might be watching this, I'm glad to say that in 2018, Jeff Hinton changed his opinion. He actually announced that the role of radiologists would evolve from doing perceptual things to doing far more cognitive things. And that's a major departure from asking us to stay home, we're not needed anymore, to saying that our role would evolve. And I totally agree with him on this. He probably has someone he's been talking to. So let's change gears and get into a bit more technical. With this, I would like to quote Kurt Vonnegut, who's one of the leading writers of the modern era in America. He's considered a luminary. He's not a scientist, though, but he's written a lot of science fiction books, so he knows a bit about science. And I like what he said about science, although it wasn't coming from a scientist. He said science is magic that works. And you're going to see a bit of magic. But I want you to understand what's behind that magic. So how do you define artificial intelligence? Artificial intelligence is the science and engineering of making intelligent machines. That term was coined by John McCarthy at the Dartmouth Conference in 1956. Just think, 75 years ago. It's a long, long time. Or is it? Yeah, 65 years ago. But this was not even the beginning of artificial intelligence. It was this man who we give credit to the idea of artificial intelligence, Alan Turing. And you could see him standing next to his machine that helped break the code of the Enigma and helped the Allies win the Second World War. And he wrote the first paper on artificial intelligence where he actually asked a question: can we make machines think? That was the question he posed in 1950. So, question that a lot of you would want to ask and probably have come across: what is AI? What's ML? What's machine learning? What's deep learning? What's the relationship? Because it's so confusing and they seem to be overlapping. This very basic slide hopefully would help you navigate your way through the three disciplines that are considered the backbone of artificial intelligence. Artificial intelligence started in the 1950s as a concept, and it's a science of getting machines to mimic the behavior of humans. And in fact, improving on what they can do. Machine learning, which became all the rage in the 1980s, is a subset of AI that focuses on getting machines to make decisions by feeding them data. Deep learning is another subset of machine learning that uses neural networks concept to solve complex problems. And by neural networks, I mean the concept of having machines work that's loosely based on the work of the human brain, of the neurons within the human brain. So you can see that artificial intelligence, deep learning, and machine learning are all interacting, and they're interconnected fields. And the role of machine learning and deep learning is to aid artificial intelligence by providing a set of algorithms and neural networks to solve data-driven problems. That's the definition of artificial intelligence. So it's very important, before I get into the workings of artificial intelligence, that we touch on the traditional computation workings. How do traditional computers work? What is programming in a traditional computer? It uses what's termed the prediction theory, whereby a computer is fed with the rules and with the data, and the data interacts with the rules. The rules are the program to give us the answers. So when we have rules or algorithms or program and we send data to be interrogated by this program, we get answers. This is the basic traditional program. This is the basic workings of a computer. Artificial intelligence does not use programming that are handwritten such as these for traditional computers. Because if you want to interrogate a huge amount of data, you're going to spend years writing programs. These programs are millions of lines long that are handcrafted by humans. And basically, the scale of writing such programs for artificial intelligence is going to be unattainable. So how do we handle machine learning? We have to give a helping hand to our traditional programming. And the way we do it is we split the process into two phases. Number one, the learning phase, whereby a computer is fed a huge amount of data and the answers. So you are going to give that computer data and answers to this data. And the computer would work out the program that would provide such an answer. I'll give an example to this that would definitely make it easy on you. And then the second stage is the prediction, which is traditional computers. That's how a traditional computer works. But in this case, it takes a rule from the previous phase, from the learning phase. So the rule is not handcrafted by humans. It's actually provided by a machine for us. And we send in the data, interrogated by the rules, and we have our answers. Okay. Now, let's look at an example of how a traditional computer works. If we give the computer a rule and say, for all numbers that we enter, I want you to add them up. And then I enter my data, which is going to be, let's say, it's just two numbers, 3 and 3. So what does my computer do? It adds them up. It gives me the answer. It's 6, because I've got the rule. It's the add, it's the addition. That's my rule. That's my program. If you see numbers, add them. It adds the numbers that I feed. I fed 3 and 3. It gave me 6. Let's see how we could utilize this example to further our knowledge of artificial intelligence. Now, in the learning phase, I'm going to tell my computer that my answer is 6. So I'm letting my computer in on my answer. I'm going to say the answer is 6 and the data is 3 and 3. What kind of program can you make for me? Whenever I give similar data, I'll always get such answer. So the computer decides that the only program that would provide such information is addition. So the computer provides me with a program that does addition, because I told him, my data is 3 and 3, I want my answer to be 6. That's my answer. And he said, okay, the program is going to be plus. Multiplication doesn't work, division doesn't work, subtraction doesn't work, it's going to be plus. Plus, yes, it works, that's my rule. Now I take that my rule to the second stage. And that's my rule. My rule is addition. What will that do to my data? It will add it up. So my data here is 2, 3, 4, 5. And interrogated by my new rule, I get my answer. It's 14. So my rule was not handcrafted. It was not made by humans. It was made by a machine. So machine learning if we go beyond numbers, if I tell my machine, I'm going to feed you with lots of data, lots of pictures, but the answer to all these pictures is going to be cat. So all the cats that I feed, the system would look at their characters and try to come up with a program that would recognize features from these pictures, features from these pictures that would have the profile of a cat. So the rule is cat features. How did the machine get the rule? By analyzing the features from all these pictures. So next time, I take this rule to the prediction phase and I feed data that has a new cat. System has never seen it, but it will look at the profile of that picture. It will break it down. Does it have whiskers? Does it have ears? Does it have eyes? Does it have a tail? Does it have fur? Is it fair colored? And if the rule sees all of that, then the answer is going to be, yeah, you've got a cat. But if it's a dog or a horse, we'll say, no, it's not. Now let's look at an example that I really like, and I think that would really clench the diagnosis for us. We have all these pictures of cats, and we go to our double process, a learning phase, which is sample data, expected result, computers, and the model, and we take that model and feed it into the computer with the new data. The computer does the magic and we get the answers. Okay, let it be more visual. So the sample data, I'm feeding my computer with so many pictures of cats, just like I showed you. And I'm gonna tell my computer, these are cats, that's the answer. Give me a model, give me a program that would recognize the features of a cat. And that model is gonna be programmed into the prediction computer, and I'm gonna send a picture of a cat that the computer has never seen. And the computer would analyze that and would say, oh yes, it's definitely a cat. It's got the features that fit the program that we've developed in the previous phase. How about a dog? Computer tries to work out, breaks down that picture and subjects it to the model, and computer say, no, it's not a cat, it doesn't fit. So that's how artificial intelligence works in brief. Okay, sounds good, sounds logical, it's not as difficult as you might have thought, but why now? Why all the rage now? Why wasn't it 20, 30, 40 years ago? Simple. We didn't have big data to teach computers. We didn't have computer power to process such big data. We did not have machine learning or deep learning. Past 10 years, all of these have really come to the forefront, in addition to one major motivation: money. There's so much money to be made in artificial intelligence. So now artificial intelligence is everywhere. How did it evolve? It evolved from being narrow to general to super. Right now we're at the narrow phase where it just does a few tasks. General, that's what really competes with humans because it does all tasks. Super AI, that's again in the future. That's when computers will be better than humans, probably developing consciousness of their own. And this is really worrying, but for all intents and purposes, this is only hypothetical. Now let's change gears once more. We've got like, I think, 5 more minutes. Types of imaging AI is from that assists the radiologist or replaces the radiologist or extends its abilities. Let's see how it can help in a radiology workflow. Our typical radiology workflow goes like this: pre-imaging, imaging, reporting, post-reporting, and back to the patient and referring physician. I'm sure you'll agree that's a very simplified workflow that's typical of most of our facilities. So what can AI do to change that workflow? The pre-imaging stage, it definitely helps with the clinical decision support, picking up the right examination for the right issue we have at hand. It optimizes the scheduling. It enhances the digital communication. For the imaging techs, it reduces scanning time and increases scan quality using AI. And it reduces dose through smart dose management. And it allows for on-scanner detection. We could be scanning a patient with hemorrhage of the brain. And the system would pick up that hemorrhage and would alert the technologist, who would alert the radiologist, who would alert the referring physician. These are things that are happening right now. For the radiologist reporting, it gives the diagnosis suggestions, gives the clinical decision support, natural language processing, and automatic report creation are things that AI is helping us with. Optimizes study routing to the best radiologist for the job. It optimizes interpretation and imaging and data, the hanging protocols, segments, analyzes the images for you. You don't have to do that. So the tedious tasks are done by AI. But post-reporting, so the admins and the techs, they get auto notification, they get auto scheduling, they even schedule appropriate onward examination. So if a report says for follow-up, automatically the scheduling system is alert and do. One more step that we see happening is the pre-imaging. Some of you might have Alexas or Google Home sitting on their desks or next to their beds, and we could see that these systems, listening to us all the time, can actually monitor our health. So if you're coughing, a bad cough, it can characterize that cough and perhaps contact your doctor and says, oh, Ahmed has a bad cough. You'd better check on that. I believe it could be so-and-so. Anyway, just to be on the safe side, I booked a CT scan for him of the chest. This is something that's expected to be with us in the very near future. Anyway, AI is not just for imaging, as you probably know. It's for cardiology, ophthalmology, pathology, dermatology, psychology, psychiatry, EEGs, EMGs, gastrointestinal endoscopies. It's there. So what we've seen over the past few years is total metamorphosis of imaging. It's not just change. And it's just like a butterfly coming out of a pupa after being a larva in an egg. So this is not change. This is total disruption. And I think metamorphosis is the word I can use. That's what AI is doing to our practice of imaging. It's metamorphing it. It's bringing out that beautiful butterfly. So AI is the ultimate transformer. Okay. We've come to the end of my presentation, but those of you who know me know that I have a crush on art, and Leto is a great friend of mine, an amazing artist, few years older than me, but definitely feels much younger. He's always optimistic, always colorful, as you can see in his shirt and his paintings. And I've managed to get 3 t-shirts from him for giving away to the first 3 emails with the correct answer that I get for this assignment. So please take a snapshot of this, screenshot. Send me your emails. The faster you do, the better chance you have. I will leave the t-shirts with Ashik. These are hand-painted t-shirts. So these are really precious. I just want to tell you that starting price for any of latest paintings is 2,000 dirhams. That's where they start for small paintings. So you're getting a t-shirt that's hand painted by him, and that's unique. It's only one piece, so the three are going to be different. No two shirts are the same, and I wish you luck with this assignment, with this puzzle, and look forward to meeting you again, maybe next year, maybe before, but good luck with AI, and I leave you with that beautiful photograph of Sharjah, and I wish you the best of luck. Great being with you guys.
Thank you, Professor Ahmad El-Sarafi, for sharing modern and advanced presentation regarding artificial intelligence.
It's been a pleasure.
Yes. To all participants, please feel free to write down your question in Q&A box that you can see on your screen.
Well, and voila, Atif, that's a great question. Is AI going to replace radiology technologists? No, but it's not going to replace radiologists either. There's going to be more need for radiologists and technologists, because we as radiologists, as technologists, it's part of our work to use technology, and this is technology. So for technology to perform, you need users, you need professional users. And this is where we come in, technologists, radiologists. And that's what Jeff Hunt didn't understand. He thought that it was going to be easy for AI to replace us. No, it's not going to happen. In fact, we're going to have a greater role in what we're doing right now. So that's for Walla. Oh, thank you, Balana, for thank you.
Is there any more question?
I'm reading a few comments. All seem to be positive, and thank you guys for interacting so positively with that lecture or presentation. And I really want to see you interacting with the technology itself, and it is within reach. And I sure hope that soon enough you will see it in your departments and you'll be using it in the best and fullest capacity. Now I have a question from Musa Bashir. Most vendors are working right now to build in AI features on future machines so that images could be diagnosed right away. For example, in case of CT trauma, it's human and machine work. Yes, that's a comment that I totally agree. And remember that right now we're in the era of narrow artificial intelligence. So an artificial intelligence application does not do everything. It just answers a question. So like in CT, the applications you're talking to, when it comes to CT, the question being asked is, do we have blood in these images? Is there hemorrhage? But it will not tell you if there is infarction, for example, or tumor, or exostosis. It just answers the question. It's just like a hammer. It's good at pushing a nail down a piece of wood, but it wouldn't do much else. It wouldn't even be able to extract it. So narrow artificial intelligence is what we're doing, is what's available now, but that leaves a room for us to do a lot of the other tasks, but also it gives room for developers to develop more applications to do more tasks. And this is what I'm going to see in the future. But it's man and machine working together. So well said. That's you're absolutely right. Oh yes, I have a question whether AI could be used for advanced imaging like MRI. That was from Robin Phillip. Yes, and it's being used right now for a lot of applications in AI, especially in cardiac imaging. Cardiac MRI depends now a lot on applications that are AI based. Yes, absolutely. So anyway, all aspects of imaging, but not just imaging, a lot of medical disciplines can or stand to benefit from AI, but especially imaging, because that pattern recognition part of imaging that we're so dependent on is done so well by AI. So yes, I wonder if we have any more questions. Is it implemented? I have, okay, Prasad, is it implemented at UE? Yes, it is. I personally have it in our facilities. We rely a lot on it, on AI, not on everything, but a lot of the applications we use AI for, but not just me. I think MOH also is using AI in its preventive health clinics for chest reading or preliminary chest reading. So a few facilities have started using AI, and I see their number increasing significantly in the future, very quickly. It's accessible now, it's available, and seeing is believing. And when people get to see it, they're convinced, because it's like magic. But again, that's why I used Kurt's words. Magic, when it works, when it delivers, is science. So this is the science behind the magic. Okay. I have, thank you very much. And I have Medina. ولقد كرمنا بني آدم بالعقل الحمد لله. Is it still? Absolutely. I agree. I usually keep religion out of my talks, but yes, if it weren't for the human mind, we would not have AI with us. Who do I send the magic answer to? My email. I have my email below that puzzle, so I'll be checking out the answers myself, and the very first three will get the t-shirts, which I'll leave with Ashik. So he will have them, I believe, by tomorrow. And again, another thank you. And I really thank you for interacting so actively and for really getting the sense of my presentation. The one thing I wanted you to know is AI is not intimidating. It's there to help us. The basics of AI are actually simple. It's when you dig in deep, that's when it gets complicated. But you don't need to dig in deep. You just need the basics to embark on your journey with AI. You do not need to be a computer scientist. You don't need to be another Einstein. You just need to understand the basics to make most of what you have in hand. And I hope with that presentation, which I'll be sharing, by the way, with you, I'll leave with the organizers of the conference for your per user. Please feel free to use it. I'm always happy when you can make some use, when my audience makes use of my presentation. So that actual presentation would be left with the organizers. You can always ask for that presentation to be mailed to you. Okay, I think there are no more questions. Anything else I could help with?
Thank you, Professor Ahmad. You take us for a world of artificial intelligence. Thank you so much. It was really fantastic. Really.
It was a pleasure giving that presentation. I was really happy with the interaction, and I'm sure with such interaction, these are the right kind of people to work with artificial intelligence.
You make us a tour through the artificial intelligence.
No, it
was very fantastic, really.
It's a huge step forward for us, and we, more than anyone else working in the field of imaging, are ready to embrace that technology and make the most of it, more than anyone else. So I really want to see everyone getting on that journey and starting his journey with AI. And as I said, it's not as complicated as it seems. It's not as intimidating. It's your friend. Make it your friend and use it. Okay.
Sir, you want to share your email ID with the audience?
Yeah, I did actually. It's on.
You can put in the chat box, please.
Khaled, could we? Let me put it on the chat box. Actually, I'm gonna put it there. That's it. That's my email. Are we good? I know I think it's break now, right?
Yes, doctor. We will have our 15 minutes break, but
Yeah.
I think it will
Okay.
be 5 minutes.
Well,
Because we will be,
I know.
it should be 10:30
Yeah,
actually.
I know I did encroach on the break time. I hope I'm forgiving for that, and I hope they don't hold it against me. But
And
again,
Dr. Ahmad, sir,
yeah.
I think Dr. Jagdish already sent the answer for you.
Oh
You
my
can
God!
check it out.
So that's one T-shirt gone. So
Okay.
one down, two more to go. I'll check my email and.
And Miss Belicini, I think we will go for 10 minutes break.
Okay, sir.
So it's break time, and guys, good
Yeah.
luck with the rest of the conference.
10:35.
10:35. Okay. Thank you, Dr. Ahmed.
Thank you. Great talking to you guys. Take care. Bye.
Bye.
Catch up later.